Okay, welcome back to McNab Chemistry. Today we're going to have a look at our common error green pen page for chromatography and RF values. Okay, so what we'll do is we'll go through some questions that have come from the Educate formative assessment resource and have a look and try and understand why the answers are what they are. Okay, so the first question that came up, which quite a few people got wrong, was an experiment was done to find out which artificial colourings were present in 2 soft drinks. Okay, the results are shown below. Which of the known colourings W to Z was present in drink 1 only? Okay, so this is drink 1, this is drink 2, and these are the known food colourings W, X, Y and Z. Okay, so drink 1 here contains these 2 dyes. Drink 2 contains 1, 2, 3 dyes. Okay, so drink 1 contains dye W, and drink 1 also contains dye X. Drink 2 contains dye Y. Drink 2 also contains dye X. Okay, so there we are. Right, so let's go back to the question. Which of the known colourings W to Z was present in drink 1 only? So this is drink 1. It's clearly W was present in drink 1 only. Okay, because X was present in drink 1 and in drink 2, because it lined it. They had a dot there which lined up with both of those 2 dots. Okay, so the answer there was W. Okay, next question. This is just useful to know. True or false? We can use the melting point and boiling point of a substance to identify it. Well, all pure substances have exact melting points and boiling points. Okay, so the answer to that is true. So if you've got a pure substance, it's going to have an exact melting point and an exact boiling point, and you can look it up in a book and that will tell you exactly what the substance is. Okay, the third question then. A scientist carried out an experiment to find out which artificial colourings were present in 2 soft drinks. Look at the results below. Which of the known colourings W to Z was present in both drinks? Okay, so X, the food colouring X moved that far up the chromatography paper. Okay, and drink 1 and drink 2 had a dot that was in line with X. So X is the answer, because you can see that I've got a dot there that lines up with that dot. Okay, so X is present in drink 1 and in drink 2. Okay, so the answer for that was X. Okay, number 4 then. This is all about calculating RF values. Okay, so this gives us an indication. An RF value gives us an indication of how soluble a solute is in the solvent. The more soluble the solute is, the further it will travel up the chromatography paper from the start line. Okay, so there's my start line, and you can see substance 1 travelled 11 millimeters from the start line. Substance 2, 15 millimeters. Substance 3, 31 millimeters. Substance 4, 4 millimeters. Substance 5, 22 millimeters. Okay, so this is my starting line. So all my solutes are placed on the start line, and the solvent front went all the way up to there. Okay, so the solvent travels up the paper and it takes with it different solutes. Okay, so my solvent front travelled 35 millimeters up the paper from the start line. Okay, so to calculate your RF value, you take the distance moved by the sample divided by the distance moved by the solvent. Okay, it's quite difficult to read this, isn't it? It's the yellow colouring, but there we are, we're fine. The distance moved by the sample divided by the distance moved by the solvent. So I'm trying to find out an RF value for sample 2. Sample 2, the distance moved by the sample was 15 millimeters. The distance moved by the solvent level was the solvent was 35 millimeters. So the RF value is 15 divided by 35, which comes out at 0.43, and that's the correct answer. Okay, so 15 over 35 equals 0.43. That's my 15 millimeters, because that's the distance travelled by the sample, and the distance travelled by the solvent was 35 millimeters. So 15 divided by 35 is 0.43 to 2 decimal places. Okay, right, and then finally question 5. Okay, so again, look at the diagram, calculate the RF value for sample 1 to 2 decimal places. Okay, so remember what RF value is. It's the distance travelled by the sample divided by the distance travelled by the solvent front. Okay, so for the substance 1, it's 11 millimeters divided by 35 millimeters, which equals 0.31, and the answer was 0.31. Okay, so there we are. Those were the areas where most problems occurred. Thank you for watching. I hope that's been helpful, and don't forget to like and subscribe and click on the bell notification to stay updated.